In this video, I will show you how to divide complex numbers such as these. The key is that we do not want any I in the denominator. We want to get rid of I somehow. And the way to do that, if you have a binomial, is to multiply by the conjugate. Now, if I have 4 minus I, the conjugate would be 4 plus I. So you just change the sign of the imaginary part, but not the real part. Now, to avoid changing the value of the problem, I need to multiply by 4 plus I over 4 plus I. So I need to multiply by the same thing in the numerator. So let's go ahead and do this. In the numerator, I'm going to have to do the distributive property. So that is going to give me 12I plus 3I squared. In the denominator, I'm going to double distribute. So first I distribute the 4, and I get 16 plus 4I. Then I distribute the negative I. So that's negative 4I minus I squared. Okay, so now I squared. Please remember that I squared is equal to negative 1. So this is negative 1, and this I squared is actually negative 1. So in the numerator, that will give me 12I minus 3, because 3 times negative 1 is negative 3. In the denominator, these cancel out. Okay, so what I really have is 16 minus negative 1. 16 minus negative 1 is the same thing as 16 plus 1. So what I will have now in the denominator is 17. Now, these are backwards. Standard form for a complex number is A plus BI. So the imaginary part must go second. So when I switch these around, it becomes negative 3 plus 12I. Now, remember that A plus B over C is the same thing as A over C plus B over C. So what you should do is separate this into two terms. So this will become negative 3 over 17 plus 12 over 17. And I'll just go ahead and put the I off to the side. So you can see that it is now in standard form. So that would be your answer to number 17. All right, let's do the same thing with number 18. Now, you know what? Before I even start this problem, I'm noticing that all 4 of these numbers are divisible by something. Okay? All 4 of these numbers are divisible by 2. Whenever that happens, you really should go ahead and simplify that before you even get started. So let's divide everything by 2. That's going to give us 3 plus I over 2 plus 4I. So this is a simpler problem, so this is what we should use. So to solve this, we need to multiply by the conjugate of the denominator. So 2 plus 4I, the conjugate is 2 minus 4I. So I will multiply by 2 minus 4I over 2 minus 4I. So I'm going to have to double distribute in the numerator and the denominator. If I distribute the 3, I'm going to get 6 minus 12I. If I distribute the I, I'm going to get plus 2I minus 4I squared. In the denominator, if I distribute the 2, I'm going to get 4 minus 8I. If I distribute the 4I, that's going to give me positive 8I minus 16I squared. Now, I squared is negative 1. Okay, so I've got a negative 1 here, and I've got a negative 1 here. So that's going to make this become, let's see, so I've got 6 minus 12i plus 2i plus 4 because of the I squared being a negative 1. And down here I've got 4 minus 8i plus 8i plus 16 because of the I squared. Now, combining like terms, 6 and 4 make 10. So I have 10, negative 12i, positive 2i, that's negative 10i. These cancel out. 4 plus 16 is 20. So I have this. Now notice that all three of these are divisible by the same number. All right? All three of these are divisible by 10. So if I do that, that's going to give me 1 minus I over 2. Okay? So that's one form of the answer, but we should really split this apart using a plus b over c is equal to a over c over plus b over c. So doing that, I'm going to get 1/2 minus 1/2 I. Okay? You might have thought I was going to put I over 2. But remember, this I is like having one I. So see where I'm getting the 1/2 from? So it's better to write it like this. 1/2 and then put the I off to the side. Alright? Sometimes I just put the 1 right here to make it more obvious what I'm doing. There's my 1/2 I. Okay? So that's it. So this is the final answer for number 18. Okay, for number 19, before we do anything else, let's go ahead and do the distributive property right here. So that's going to give me 6i plus 8i squared over negative 2 minus 3i. Okay, now we can multiply by the conjugate. Wait. I squared is negative 1. So we need to deal with that. This I squared is a negative 1. So that means I would have, this is going to become a negative 8. And I'm going to go ahead and put it in the front and put my 6i last. So we have standard form. So then negative 2 minus 3i. Now I will multiply by the conjugate. The conjugate here is negative 2 plus 3i. Notice that the negative 2 does not change. So in the numerator also negative 2 plus 3i. If I double distribute in the numerator and the denominator, if I distribute the 8, I will have 16 minus 24i. If I distribute the 6i, that's negative 12i plus 18i squared. Now, if I distribute the negative 2, that's 4 minus 6i. If I distribute the negative 3i, plus 6i minus 9i squared. Okay. Now, I squared is negative 1. Okay, that means instead of plus 18, I'm going to have minus 18. Instead of minus 9, I'm going to have plus 9. Okay, so I'm just going to bring down the rest of it. You know what? I think I will go ahead and cancel these out though. So I've just got 4 plus 9. So combining like terms and such, 16 minus 18, that's negative 2. And then negative 24 and negative 12, that's negative 36i over 13. Now let's separate these into two separate fractions. So I will have negative 2 over 13 minus 36 over 13i. So this will be your final answer for number 19. Okay, for number 20, we need to multiply all this out before we even get started. So let's do that. Okay, so look, first I'm going to do this right here. I'm going to go ahead and double distribute these two things. So let's see what I get. So if I distribute the 2, that's going to give me, hold on, distributing the 2, that's negative 6 plus 8i. Now distribute the negative 2i. That'll be positive 6i minus 8i squared. Okay, and then I still have the 3i out there. Let's double distribute this. Distributing the 2, I have 6 minus 4i. Distributing the I have 3i minus 2i squared. Okay, now the I squared is negative 1, right? Okay, the I squared is negative 1. Okay, that means that instead of negative 8, I will have plus 8. Instead of minus 2, I will have plus 2. Okay, so I'm just going to bring the rest of it down. So I have 3i negative 6 plus 8i plus 6i. And down here, I have my 6 minus 4i plus 3i. Okay, so combining like terms. So I've got this 3i. Okay, let's see, negative 6 and 8, that's 2. 6i and 8i are 14i. Let's see, 6 and 2, that's 8. Negative 4i and positive 3i, that's negative I. So I've got this. All right, now I'm going to go ahead and distribute the 3i. So that's going to give me 6i, okay, plus, 3 times 14, so that's 30 and 12, so that's 42. All right, so I've got 42i squared over 8 minus I. Well, I squared, of course, is negative 1. That's going to make this a negative 42. I'll go ahead and put that in the front. So I've got negative 42 plus 6i over 8 minus I. Okay, great. So basically now we begin the problem. All right, it's like we're just getting started. Because now, and you know, I'm going to switch colors even because like I'm starting over. So now is where we multiply by the conjugate. So 8 plus I is the conjugate of the denominator. Okay? All right, so let me just separate this off. So I'm going to double distribute here. Let's see, 8 times 42. Okay, that's 336. All right, these are awful big numbers. So I've got negative 336. And then negative 42 times I is just negative 42I. Now distributing the 6I, I'm going to get 48I plus 6I squared. All right, now in the denominator, distributing the 8 gives me 64 plus 8I. Distributing the negative I gives me minus 8I minus I squared. Okay, now let's see, how much space do I have? I'm running out of space. I'm going to squeeze it in here. I squared is negative 1. Okay, so what I'm going to have is, I'm just going to bring this down. But this will be a minus 6 because times negative 1. These will cancel each other out. So I have the 64, but then I have minus negative 1. So that is a plus 1. Okay, so this came over here, the flow. I ran out of space. So combining like terms, I have negative 336 minus 6. That's going to be negative 342. Okay, negative 42 plus 48, that's 6. So it's going to be minus 6I over 65. Okay, and just splitting this apart, I have negative 342 over 65 minus 6 over 65I. So this will be the final answer to the longest simplifying complex number problem ever. That's going to be the end of this video. I'll see you on the next video if you want to see how to graph complex numbers and find the absolute value.